Welcome to everyone who's joining us for the webinar today. We are going to get started in just a minute and give folks a chance to get logged on and settled, and then we'll get going. So welcome, welcome. We'll give folks just a couple more seconds here to get logged on and join us, and then we'll go ahead and get started. So thanks for making the time to get together with us today for our initial webinar of the four-part series on the intersection of energy and community. Great. All right, looks like we've got quite a few people still coming in, so we'll just give people another couple seconds here, get settled, and then we'll get going. Great. Okay, well, let's go ahead and get started. Welcome and thanks to everyone for joining us today for part one of Fresh Energy's Intersection of Energy and Community webinar series. I'm Margaret Cherney-Hendrick, Lead Director of Energy Transition at Fresh Energy. Fresh Energy is a Minnesota-based nonprofit working toward a vision of a just, prosperous, and resilient future powered by a shared commitment to carbon neutral economies. The evolution from a world powered by oil and gas to a clean electricity powered future is playing out in our neighborhoods, workplaces, and homes. But it's not just communities adapting to change. Cities, counties, local institutions, and businesses are often leading the way. Today, we're going to discuss how district scale community heat and power projects can achieve big carbon reductions and new union jobs in a way that improves our communities and benefits everyone. We know that greenhouse gas emissions are increasing at the fastest rate across the building sector in Minnesota. Since 2005, emissions have increased 32% from residential buildings and 15% from commercial buildings, primarily as a result of on-site combustion of fossil fuels like natural gas. As we tackle how best to reduce these emissions, community heating and cooling will be a big part of the solution. So before we get too far along, I just wanted to extend a shout out and thank you to all of our promotional partners who helped spread the word about this event. Thank you to AIA, CERTS, Climate Gen, Midwest BDC, Minnesota Electrical Association, MNSEA, Pollen, RMI, Sierra Club, the Nature Conservancy, and WSB. Now, I'm very excited to be joined today by Brian Larson, co-founder and CEO of Darcy Solutions, and Tony Poole, business manager of the Steam Fitters, Pipe Fitters Local 455. We're hoping that our guests today and those listening later to the audio recording of our webinar in podcast form leave with an understanding that building ground source district heating and cooling systems and retrofitting existing district heating and cooling systems to be carbon free are a way to reduce carbon emissions. They're super energy efficient and a major opportunity for union jobs in all areas of the state. We're going to start with a panel discussion and then move into a Q&A for the last 15 minutes or so. Many of you submitted questions in advance, but if you didn't, please use the Q&A box at the bottom of your screen to send in your question, and we'll do our best to get to as many as we can. And just to differentiate, there's a Q&A box and a chat box, so use the Q&A box, please. And you're also able to upvote questions. So if a question has already been asked that you are very interested in getting answered, please upvote that question. We're going to be covering a lot today, so I want to dive right in. Brian, could you tell us a little bit about yourself and Darcy Solutions?
Yes, thank you, Margaret, and thank you, everyone. Really happy to be here and have the opportunity to talk with you about what we're doing and how we're working with Tony and his group. So thank you very much for the time. I've been in the energy industry really since the beginning. After graduating, I went to work for Chevron on the dark side of energy, and have now transitioned over to the clean side. But energy has been a deep interest of mine for a long time, and particularly so over these last several years. My co-founder, Dr. Jimmy Randolph, and I started working together almost exactly 3 years ago. We got introduced through the University of Minnesota's Office of Technology Commercialization. And what they do is they pair people like Jimmy and myself, where they take a science researcher at the university and pair him with a business person and with a background like mine. And that's how we started to work together. Since working together, what we've been focused on is taking the ideas that Jimmy and his team had been working on in the laboratory and bringing them to fruition, taking them out of the lab and bringing them into the field, into a real world setting. And so we've done that with our first system, which is actually with Tony and his group at the Pipe Fitters Local 455. And so very excited to use this as kind of the foundation for our conversation today to talk a little bit more about what it is we're trying to achieve. And I think just one more point about Darcy, our mission is really focused on how can we have as much impact as broadly and as rapidly on cleaning the environment. We're really excited about what geothermal or ground source technology can mean in terms of building heating and cooling. And so by making it more broadly available, we think we can have a real impact. So again, we're really excited to be talking about this. And Joe, if you want to put a couple of the slides, this would be a good opportunity for a good transition and introduction. And what these are, the backdrop for the project at Pipe Fitters. So thank you. So Margaret, did you want to turn it over to Tony, or do you?
Yes, and just to answer a couple questions that have come up, the recording of this webinar is going to be available later today. So thanks so much, Brian, for that great introduction. We'll be able to share those slides again too for folks to kind of look through more closely. And Tony, let's turn it over to you for a quick introduction.
All right. Well, thank you, Margaret, for the opportunity to be here to talk about our project today. Like Margaret said, my name is Tony Poole. I'm a 23-year member of Steam Fitters, Pipe Fitters, Local 455 here in St. Paul. I began my apprenticeship in 1998. I worked the bulk of my career in the field as a welder on everything from heavy industrial to school jobs. In 2009, I was elected to serve on the executive board for a 3-year term. In 2013, I was elected as a full-time business agent until 2018, when I was elected business manager, which is my current role. Local 455 represents over 1,600 licensed and certified steam fitters, pipe fitters, and HVACR service technicians, covering 22 counties around the St. Paul and Mankato areas. Some of the work that our members perform on a daily basis is industrial piping systems, making critical welds, rigging, all types of heating and air conditioning systems, district energy, all types of refrigeration systems from grocery stores to cold storage, temperature controls, and HVAC service, just to name a few. We're a very broad trade. Our local was founded in 1904. A large portion of the work that we have performed and somewhat still perform has been in the fossil fuel industry. We've noticed over the last 10 to 15 years, our members have been seeing a lot of changes in the energy sector away from the fossil fuel industry. Understanding that these transitions are necessary to reduce carbon emissions, it leaves some of our members trying to figure out where they're going to fit in going forward. That brings us to where we're kind of at now. We all amongst the local talking about what we're going to do, and I had the idea of looking into geothermal. So geothermal is a clean, efficient way to provide heating and cooling, has a potential to put many of our members to work and keep them working. So a couple of years ago, I decided to look into converting our 100,000 square foot training center from gas-fired rooftops to a geothermal hydronic heating and cooling system. We sent out multiple RFPs to our signatory contractors and received multiple bids back. Ultimately, the decision was made to proceed with the project, and we went with Horowitz Mechanical to do the mechanical inside of our building. By doing this project, this will not only reduce carbon emissions and lower electricity usage, it will also be a great way for us to promote geothermal technology. More specifically, the Darcy technology, which we discovered early on in the planning process, which turned out to be an excellent decision, and really happy that we were able to find them. After meeting with Jimmy and Brian at Darcy and learning about their design, we realized how much potential this system has. That being said, we wanted to be on the forefront of this technology and be the first building in the country to use this type of system. Our hope is that more and more people will see the advantages of geothermal, specifically the Darcy system, thus creating good paying union jobs for our members. And I look forward to getting into more detail throughout the conversation.
See, and we're looking through a few of the photos of the local 455 retrofit project that Tony has provided. It's great. Okay. And for everyone who's interested in seeing the slides, we'll have those up on our website as well. So you'll be able to take a closer look. Thank you so much, Brian and Tony, for making time to join us today for the conversation. So let's go ahead and just dive right in. I'm wondering, how did your collaboration, Brian, with Tony on the local 455 training center demonstrate how this transition in the building sector, so moving away from gaseous fuels like natural gas to ground source systems and heating and cooling systems in particular, might advance? So what did you learn from this project?
Yeah, you know, it's old ways die hard, I think is the expression. You know, I really have to applaud Tony for being a visionary here. There are a lot of different parties who are involved in making a decision like this. A lot of expert advice is given, and those experts are familiar with traditional technologies that are well proven, well established, and are known to perform, and that they won't present any issues going forward, or if they do, those issues are already known ahead of time. To do something different, to try something different, really takes a level of resolve and vision to say, hey, let's keep looking at this. I know there's you can give me 5 reasons why this isn't going to work, but I want to look at it. I want to keep trying, and I want to figure out a way to make it work. And you know, Tony has stuck with that. He's seen the bigger picture for why that's of value. And it has meant overcoming, I think, a lot of resistance within a number of different arenas, whether it's the mechanical engineer designers, whether it's the design build side, whether it's the architectural side, whether it's the regulatory side. To do something different is different. And so that takes quite a bit more energy to get it done, and to have the resolve to you know, expend that energy to make it happen. It's really an impressive thing to do. So that's kind of the lesson, that this has to be driven by the end user, somebody who's really passionate about it, somebody who's willing to push against sort of that natural resistance and bring it to fruition. And we've seen that clearly in this project working with Tony.
Great. Thank you so much. And Tony, how did your collaboration with Brian on the local 455 training center demonstrate how this transition is going to create significant opportunities for family sustaining jobs and clean energy?
Sure. You know, working with Darcy has been a great experience, learning about their technology. When we did, you know, we were very lucky to find Darcy. It was kind of I was talking with a colleague of mine a couple of years ago, a business partner, and telling him that we were looking at doing a geothermal system, and they actually got me in contact with Jimmy, and that's how we ended up finding them. And it turned out to be great because the technology and the potential that the Darcy system has versus a traditional geothermal system, which we were originally planning on using, totally outweighs the original system. Not just because of what it does, but because of the job opportunities that projects like ours can create. Promoting this technology has become like a second job for me, like we had talked about before. Multiple times a week, we're giving tours to elected officials, community leaders, engineers, schools, clean energy groups, you name it, anybody and everybody. And you know, following the discussion today, I'd be more than happy to provide my email address for anybody that is in the area that would want to come and take a look at what we're doing. All the while, we're trying to promote the use of ground source systems like this Darcy system specifically for existing projects, and encourage them to be built with and new projects, existing projects and new projects, and to encourage them to be built with union labor. I mean, the transition that we're seeing away from the jobs in the fossil fuel industry, which are union jobs, we want to transition those same union jobs into jobs like geothermal for our members. Another thing along the lines of, you know, with that, if all public funded projects like schools, government buildings, et cetera, were to implement these systems, I think we would see a dramatic reduction in heating and cooling costs and electricity usage, resulting in lower taxes. I mean, that's a big part of the costs that these public sector buildings go through, all buildings for that matter. So we're hopeful that this project is a clear demonstration of the opportunities and a vision of how union pipe fitters and all labor can benefit from this transition.
Great, thank you, Tony. You know, Fresh Energy sees a lot of opportunity for systems like this to expand to a district scale. So interconnecting buildings with very different energy use profiles in particular, both for increasing energy efficiency, reducing carbon emissions, and creating lots of new union jobs, just like you mentioned, Tony. So if we can sort of expand the conversation beyond, you know, demonstration projects like at Local 455 to interconnecting buildings and forming these community district systems, you know, Brian, can you go first? Do you share this vision that district systems are scalable?
Absolutely. And it's another thing where it's a requirement. I mean, when you look at where total energy demand is generated, I think it's a 3-to-1 ratio on the residential side versus the commercial side, 72 to 28%. And figuring out how to be able to cost effectively deploy and scale this kind of technology is critical to having the widespread impact reduction that we'd like to be able to have. And district systems are an excellent vehicle, probably one of the best suited to bringing in those residences that maybe on an individual basis, it wouldn't make sense or there isn't a good solution for them. But if they can tie into a larger system, there are a number of advantages then that a district system can provide. First off, just that diversity of demand load, the offsetting. While this building's in heating and this building's in cooling, there's just natural opportunity to balance load, and that can reduce 8 to 12% of overall demand, providing just sort of natural sharing of energy across that district. But then there's also other things that those district systems can bring, you know, in addition to the benefits of improved health, improved comfort, and savings. There are also some very interesting models evolving where third-party ownership is starting to come into these systems, where third-party developers are making the investment to provide the district system. And that's always been a challenge. You know, how do you come up with the capital for a district system? And when a third party, whether they've learned it on the community solar side or some other sort of project development opportunity, are now looking to apply it on the geothermal or ground source system side, it's a natural synergy for them to be thinking about it, and another way just to facilitate making these types of investments that much easier.
Great, thank you, Brian. So Tony, how will the district scale ground source systems that Brian just discussed impact future commercial and industrial building sites, do you think?
Well, I think systems like this will definitely have an impact on future building sites, and we believe for sure that they can be used in a district scale system. This technology can replace the need for a chiller. We have proof of that in our building, 100,000 square foot training center. This technology can also be used for supplemental cooling, only needing a traditional chiller when in high demand, you know, and so if you have a chiller, you could install a pump and use the bulk of your cooling from a Darcy Systems exchanger. In addition to the Darcy system, in addition to this, you know, with the Darcy system, you can do so much more. You can integrate free cooling into the heat pumps within occupied spaces, eliminating the need for airside economizers. Free cooling on the Darcy system is not tied to the ambient air temperature. Therefore, there are a lot more hours of free cooling with this type of system than you would have with any other type of waterside economizer. The Darcy system in a community will allow simultaneous heating and cooling This system will then allow spaces being heated to provide free cooling to spaces being cooled and vice versa without having to go through any type of heat recovery chiller or pump. Utilizing the Darcy system, you can always also have year-round sensible cooling for all the spaces that have year-round cooling load, eliminating the need for a heat pump. If this type of system can provide free air conditioning for our 100,000 square foot training center with only 4 wells, then yes, it can be applied on a district scale. We also we have the capability to cool our building with 1 well right now. We are working on startup, and we're still working out some kinks, and we have proven that 1 well has cooled our 100,000 square foot building. So yeah, we feel that this is definitely something that can be used on a district level.
Great, thank you so much. And I wonder, Brian, before we move on, Tony just spoke, I think, really well about sort of the differences between the Darcy technology and these conventional geothermal systems. I wonder if you just wanted to say a few things about why your technology that you've developed at Darcy is sort of more efficient and can be scalable even in dense urban environments.
Yeah, great question. A couple of the key challenges that geothermal has historically faced are upfront costs. It's a premium to put it in, and the space required to put the infrastructure into the ground. And that's because the system really relies on a heat transfer mechanism known as conduction. It's a well-established process, but it's a slow process. The Darcy approach takes advantage of what's already there, namely groundwater. So often a traditional system might be in that groundwater, but it's not actively looking to take advantage of the superior energy exchange that water can provide. And so once you do that, and so our system is designed a little bit more specific to like a water well design, where we can then take advantage of groundwater and specifically and get a little technical, the advective and convection benefits that water can provide. And what that does is that in addition to conduction, groundwater then can allow you to get 10 times or maybe even 20 times the amount of energy exchange through one individual borehole of what a historical or traditional system could do. So now you can see a 10-to-1 reduction in the number of holes in the ground that you need to drill. Naturally, there's a cost savings with that, but then there's also space savings, which allows you to put these systems in, especially in retrofits where they previously just weren't feasible, or as those charts that we showed right at the beginning showed, Tony's team was looking at putting in 75 to 85 boreholes, tearing up their entire parking lot. Well, our system went in with 4 holes in the ground. So you can see the black polka dots, 75 boreholes across the parking lot. Instead, we were able to do it with 4 along the landscaping, and really hardly even having to tear up the parking lot at all while we were putting the system in. So you can imagine even more dense settings where that's a very big advantage to minimize disruption and fit these systems in where previously they weren't feasible.
Great, thank you so much. And that's super helpful. I know we were getting a couple of questions in the chat here just about the differences in your technology and conventional systems. So that's great.
Thanks for asking.
Yeah, so we're going to switch gears a little bit here. We're going to talk about, explore some barriers and opportunities to sort of moving this energy transition through community district heating and cooling systems forward. So Brian, this next question is for you again. Based on our discussion today and the work you're doing at Darcy Solutions, it really seems like this type of district heating and cooling entering the mainstream is entirely feasible. So in your opinion and your experience, what's holding up greater adoption of these systems?
Yeah. It's interesting. I think there's a little bit of that reluctance or resistance to change that we talked about earlier, just trying something new and different. But then cost, how can we demonstrate that this is a cost-effective way to do this? Natural gas is cheap and it's difficult to compete with. But as we're starting to see, a very good sign communities that have set net zero targets by 2030 are now considering making investments, for example, that are going to be 10, 15, 20-year investments. And so in 2021, if they make a 15-year investment in a natural gas-fired boiler, they're going to have a hard time hitting that 2030 net zero target. So what we're seeing is a very important shift in mindset for, well, what's the comparison against? Is it against a traditional natural gas-fired boiler? Or no, we've said we're committed to getting to net zero. So now the comparison is relative to an electric boiler. And that helps change the equation as well. So, you know, the payback and the cost savings opportunity becomes even more pronounced when you make the comparison of geothermal to an electric heating system like an electric fired boiler. So I think that will help a lot. But then I don't want to sound too much like a broken record, but there is this, how much of a visionary are you? And how much are you willing to try new things? We're hearing as well from some of the mechanical engineers, particularly in the architectural firms, who are saying, hey, there are these energy efficiency regulations, SB 2030, B3, without a technology like geothermal, it's very difficult for us to hit those regulations. What can we try? Okay, well, let's be a little pioneering and let's try some new technologies. And I think that willingness to try something new is just going to create it'll become a virtuous process, and it'll accelerate the adoption of the technology. So I think that's part of it as well, is that willingness to not sit back and wait for 10 years of performance data, but to be able to say, hey, can we get comfortable more quickly and move ahead, because these other factors are all combining to motivate us to want to do that.
Great. And we've got these projects already on the ground that can help to start to demonstrate exactly what the potential is. So
right.
Great to be having the conversation today. So Tony, we know that perception is everything, and many people might think that they know all there is to know about what geothermal entails. But what we're discussing today is not traditional geothermal. Can you talk about perception versus reality on the training center project?
Sure. Yeah, that's definitely not traditional geothermal. And I had always told Brian and Jimmy that you got to come up with some really cool name for this stuff, because we keep on referring to it as geothermal, and it kind of is, but then everybody thinks it's, oh yeah, I know what geothermal is. It's been around forever. But so I think Darcy, has become the cool name, but we wanted to make sure that we continue to tell people this is definitely not traditional geothermal. I would say it's a new cost-effective technology. It's a closed loop system that places, like Brian was explaining, an exchanger in the aquifer, and it cools the water that's being piped into our building. It maintains around a 52-degree temperature year-round. That's how we eliminate the need for a chiller or any rooftop units for cooling. Like Brian said, we went when we originally had our bids all out before we had found Darcy Solutions, we were going to be looking at somewhere between 70 to 80 wells and the complete tear up of the parking lot. And not to repeat Brian, but we are down to 4 wells, and we may have been able to even get by with 2, to be honest. That's how well the system can perform. Like I said, the cost savings, our approximate annual savings with this new system is around $26,000 per year. That's resulting in a buyback of 7.5 years for the Darcy system. I always tell people we basically have free air conditioning for our 100,000 square foot building. Just if anybody out there is wondering too, that the exchanger and the pump being placed in the aquifer, the only thing running through the exchanger is water with a softener salt, the same type of thing that's in your water softener at your house at home. So in the event if something were to crack, it's completely potable water that the Department of Health has okay, just so everybody, because I have questions sometimes. Well, what happens if something happens in the aquifer? But it's completely potable water running through the system.
Great, thanks for that, Tony. And we do have quite a few questions about the aquifer ramifications, which we'll get to in the Q&A session. So hold on to those questions, folks, and keep them coming as you come up with them. So Brian, turning to you again, there's some serious opportunities to be gained from building ground source heating and cooling systems, as well as retrofitting existing district systems to be a lower carbon intensity. So in your work, where do you see the biggest gains?
Yeah, the new construction side is, I think, the easier side of things. The existing building stock, though, is really, it's been a challenge for them to find the right technologies to get after this. And so that's where we're focused, is commercial retrofits are sort of our, call it beachhead market that we're going after, just because we think that's where there's the greatest opportunity to get started. The other nice thing about geothermal, and I really appreciate Tony's comment, it's not your typical geothermal, but geothermal technology is 2 to 3 times more energy efficient than other electric technologies, and it can provide the full heating and cooling requirements. There may be opportunities to supplement that on either end, just for cost efficiency standpoints with supplementary equipment to go with it. But if you wanted to, the geothermal system could provide the full heating load as well as the full cooling load. And that's an advantage as well over some of the other technologies that are out there. So I think the good thing is about it, it can be a complete solution, and it can be a solution that can be combined with some other technologies for additional energy savings and efficiencies and system performance benefits that you aren't able to capture with traditional geothermal or traditional ground source systems.
Great. So Tony, turning back to you, expanding on this discussion around energy efficiency. So based on your experience, where do you see the biggest efficiency gains, and how does that relate to your labor workforce?
Sure. Well, hydronic systems are the most efficient way to provide heating and cooling. Water is a better heat transfer medium than air. A 3/4-inch hydronic pipe carries the same amount of heat transfer as an 18-inch diameter forced air ductwork. There's nothing new about hydronic heating and cooling. Our members install these systems every day, but utilizing the Darcy system, they become more cost effective and more efficient and carbon free. I did have one piece of information that Todd over at Horowitz had provided me that is a little bit beyond my expertise, but there might be some people in the room that might understand it a little bit better. So, he had wrote me that with the drive to get to carbon neutral, for some developers and business owners, the Darcy system can help. Not only can you get the free cooling from the Darcy system, resulting in less electricity being used, you can also use the Darcy system to provide heating. With the use of water to air heat pump, you can get a COP of around 4. Therefore, every 1 kilowatt of power you put in, you actually get 4 kilowatts of heat out of the heat pump. Not only that, but in a water to air heat pump mode with the Darcy system, your cooling EER will be above 20. Comparatively, natural geothermal systems will get you a COP in heating of around 4 and an EER in cooling mode of around 12. A lot of that is foreign to me, but like I said, there might be some people in the room that understand what he's talking about. The EER is the energy efficiency rating, and the COP is the coefficient of performance. So just thought I would throw that in as well.
That is super helpful, Tony. And I think it's also important to note you can get that COP number to go down even further as we interconnect more of these systems in a district profile. So those are great numbers to benchmark against. So thank you. So Brian, turning to you again, it would not be a Fresh Energy event if we didn't talk about policy. So a key area of Fresh Energy's work is focused on creating and updating policy to help our buildings be built and retrofit better, last longer, and be future-proof. Can you talk a little bit about a few of the key policy opportunities you've seen recently in advancing these systems?
Yeah, sure. Sorry. I have been accompanied by my dogs here. I just had to close the door. Yeah, I think one of the big ones, and I know Fresh Energy has played a very important role in this, is the eco legislation that was just signed maybe 4 weeks ago by Governor Walz. that has been, I think, traditionally one of the challenges around fuel switching and being able to incentivize customer projects where they moved from a natural gas fired technology to an electric technology. That's a great example of helping overcome one of those traditional barriers. The other thing that I mentioned a little bit earlier, these SB 2030 standards, the regulations from a building efficiency standpoint, that also forces a level of creativity onto the building designers to think about envelope, to think about orientation, to think about vegetation, to think about, a variety of things, as well as the heating and cooling system. And typically in those analyses, they see that the heating and cooling system is the biggest component or the biggest contributor. And so having aggressive regulations, I think Minnesota is a leader in that space. There are other states in the Northeast, Washington, D.C. as well, that are really pushing similar types of regulations where they're requiring building owners to have a level of efficiency that then in turn requires them to look at technologies that can bring about those types of efficiencies. And then finally, there are other things that are happening in terms of encouraging. This isn't happening in Minnesota, but in a number of cities across the country where new developments just aren't going to have natural gas infrastructure anymore. It's just not going to be allowed. And so then that also forces a new type of creativity to say, well, how are we going to heat and cool? How are we going to cook? How are we going to dry our clothes? How are we? And that's just another form of legislation that can help influence the types of technologies that are being adopted.
Great, thank you, Brian. So Tony, turning back to you again, you're in a really unique position here with your role as business manager at the local 455, and you've broken some new ground with the training center project, literally and figuratively. If you could tell a counterpart of yours in another Midwest state about the opportunities for labor in the clean energy transition, what would you say to them?
Well, first off, I'd just like to go back to what Brian had said about the kind words that, the visionary. I don't picture myself as a visionary. I had an idea, but had a lot of help from a lot of people that are a lot smarter than I am. So, we got here together. But when you say that I'm in a unique situation as the business manager of Local 455, that with the way the world is transitioning, you're absolutely right. And we have a lot of members that are very nervous about their futures on what things hold for them. And like I said earlier, but there is a very much of an understanding of the need to transition. They're just trying to figure out where they fit in. So a lot of our members are extremely excited about this project and the potential that it has. But there's also still some nervous tensions with it on whether or not it was the right investment. So we're ready to prove everybody that it's the right path, along with other people that I've worked in the industry. We have a very broad internet of folks across the country that within the United Association, all throughout every state in the country, that our connections run deep and we communicate. Most people that I know throughout the country, other business managers, know what we're doing at this project. I think they're kind of eyeing it and kind of trying to see if it works, along with a lot of the people that we've had come in here and tour the building. I think they're looking at it as, this is excellent, this is great. Let's just see it in action. And I think once it's in action and we're going, I think this has a potential to take off. For some, the transition to free energy, it's probably feels like it's or to clean energy, probably feel like it's happening too slow. And that, like, just from a pipe fitter's perspective, or somebody that has worked in the fossil fuel industry, and our members have, it's happening very fast for us. So it's very important for us to do something like this. In our world, our technology changes all the time, whether it's a new weld procedure or a new material that our pipe is being used. So new hangers, whatever the technology might be, we adapt to that technology, and then we readjust our training center and we train our members. So I look at the transition to a carbon-free clean energy as the same thing. We need to learn to adapt. We need to learn to adjust. And the Darcy systems and this geothermal technology, I think, is a great way for people in our industry, pipe fitters in general, to transition from the coal industry into green energy. We believe there's many opportunities for pipe fitters going forward, not just geothermal, but also with technologies using green ammonia and hydrogen as a carbon-free fuel source, just to name a couple. Ultimately, to go through this transition and maintain good paying, family sustaining jobs, and they need to be union. And not to repeat myself, but the jobs that we're transitioning away from are currently union jobs, and we hope the jobs we transition into will remain union jobs. And if every building in the country were to start implementing systems like the Darcy system, whether existing or new, our members all across the country would have more work than coal ever provided for us. So it might take a while to get there, but we believe, and I want to believe, that hopefully our building someday is looked at as the start of that. And it would be a great way to transition out of coal, that the steam fitters are the ones that put it in their building, and now we're putting it up everywhere. And I think that would be an excellent story long term. And like I said, quality labor isn't cheap, and cheap labor isn't quality. So we hope that we're part of the transition going forward. Thanks.
Well, that's a great note to end our discussion on here. Really appreciate your guys' insight and time and expertise. We're going to transition now to the Q&A portion of the webinar, questions from you guys. But before we do, I wanted to just quickly remind everyone that the Intersection of Energy and Community webinar series will return next Thursday at noon with a conversation between my colleague, Ben Passer, lead director of Fresh Energy's Energy Access and Equity Program. He, along with Bob Blake, founder and CEO of Solar Bear, Nina Axelson, founder of Grid Catalyst, and Jamez Staples, president and CEO of Renewable Energy Partners, will be discussing the workforce of the future. So please join us for that discussion next week. And while we're on the subject of events, registration is now open for our virtual benefit breakfast with Fresh Energy on October 14th, featuring award-winning climate tech entrepreneur Danelle Bard, CEO of Brooklyn-based Block Power, an organization proving that businesses can tackle carbon pollution while making a profit and creating family-supporting jobs. You can register at fresh-energy.org/benefit breakfast. Okay, so we are going to move to your questions now. And like I said at the beginning of the webinar, we've received a number of questions that were submitted at the time of registration, and we've got some great questions that are coming through in the Q&A box. So I'm going to do my best to get to everyone in about the 15 or so minutes that we have remaining. So let's dive right in. So I think starting with the Q&A box here, a question from Joe that's gotten a lot of interest is, and this is maybe one for Brian, if aquifer source heating and cooling becomes widespread, is there potential for the overall aquifer temperature to change, or that the aquifer could become contaminated? And I think we touched on this briefly, but maybe just a little bit of a longer discussion about the aquifer implications of scaling up these ground source systems with Darcy technology.
Yeah, I think it's a good question and a very important question. For us, and Tony alluded to this, I think there is the risk of contamination question is the critical one, is the source of contamination. And that's why using potable water as the medium for transferring that energy is so important and sort of foundational in the system, so that if there ever is an issue where part of the system has a leak, what is going in back into the ground is potable water, which is different than traditional systems. A traditional ground source system often has a mixture of water and propylene glycol, and those systems are grouted into place to help prevent leaks of that fluid. But we've taken that fluid completely out or eliminated it from the the loop fluid and use just potable water. I think the other question in there is around temperature. And again, comparing that to traditional ground source systems, effectively, it's the same amount of energy that's being rejected or withdrawn from the ground as a traditional system. The interesting physics of a water-based or waterborne distribution of that energy is that that mass just reaches dramatically further, volumetrically and distance-wise, spatially. So the energy is dissipated over a much broader volume than even what traditional geothermal would be able to provide. So in those contexts, that's how we're thinking about it. But then in addition to it, we are looking at and continually measuring what is the temperature and how is the groundwater temperature being affected, if at all. And so that's part of our system design as well, because we want to ensure that that it is being operated safely.
Brian or Tony?
Yeah, I just wanted to add on to that too, just so everybody understands it, that when I was talking about a closed loop system, Brian, I mean, we're virtually just using the temperature of the aquifer water. We're not using the water from the aquifer. So we're not taking water out and putting it back in, just using the temperature of the water. And just to put in perspective, the temperature of the water, like I said, was going in at 52 degrees. And when it comes back to the exchanger, it's only coming back at like 53, 54. So, and it's not going into the aquifer, it's staying in the closed loop system.
Yeah, great clarification, Tony. And Margaret, I don't know if people recognize that the groundwater itself is just providing the heating or cooling benefit, and the fluid that goes to the building is in a completely separate pipe. And so there is, it's a closed system, so there's no direct interaction of those two fluids. In the unlikely case that there's a leak, that is what we would be worried about, where there could be communication between the two fluids, and that's why we use potable water. But otherwise, yeah, there is no direct interaction between those two liquids.
Yeah, I think that's a very important distinction. So thank you guys for clarifying. That's great. Let's see. So this next question is from Nick, and I think it's for Tony. Could you clarify, Tony, the $26,000 per year cost savings that you mentioned? Is this savings relative to the current heating and cooling cost of the training center? And is that borne by natural gas heat and electric for cooling? Or is this savings relative to the 75 well system you first contemplated?
Well, currently, before we had this system in, all of our heating and cooling was through natural gas fired rooftop units. We had, I think, 25 on our roof. We working with Horowitz, we had a study done by the Wilden Group. They came in and they looked through what your new system's going to be, and then they take old electric bills, natural gas bills, and then they compare to what the new system and how it's going to perform. And those are numbers based on the Wilden Group that they provided to us. Now, obviously, we haven't had like a full year of actual hard data, but that $26,000 number is based on from the Wilden Group.
Great. Thank you. That's super helpful. Okay, this is a question perhaps for both of you. It comes from Janet. What are one or two policies that would be most important for the city of St. Paul and the city of Minneapolis to adopt to promote the technology used in the local 455 building?
I can start. I got just my own ideas of what the cities should adopt. I believe that we should not be installing magic packs on buildings anymore. I think that whether we're utilizing current district energy systems that we have, or we're supplementing current district energy systems that we have with systems like the Darcy systems, and using these types of systems versus continuing to not use district type heating and cooling at all. So I think that a policy to eliminate the use of magic packs would be a good start.
Yeah. Yeah, and maybe to build on that, like the city of St. Paul with the net zero target 2030, having that as sort of a guiding framework really helps facilitate a good conversation around, well, what does that mean? What are the implications of that, both now as well as decisions that will take us 10 and 15 years into the future? But those decisions shouldn't be made in isolation, because there are technologies that, while they allow you to get away from carbon generation and fossil fuels, they may not be the best load to be putting onto the electric system, onto the electric grid, as we saw in Texas in the ERCOT district earlier this year. You can overload that system. And so thinking about the load profile that these technologies bring on is also an important part of the conversation. So including the electric utilities along with the city in that instance, to say, how do we do this in a way that drives up our utilization or load factors, doesn't introduce new spikes in the wintertime like we're seeing in the summertime, and that the system can handle that. And ideally, what it is it's the most efficient technology that we do bring on, because we know we're going to be plugging in more cars. We know we're going to be plugging in other things as well. We want to make sure we can get the most out of what that existing grid can provide. So I think that needs to be part of the conversation as well, is what do those load profiles look like as you bring more and more of the technology on.
Yeah, I think that's right. The winter peak that we are expecting, with more and more transition away from fossil fuels and buildings towards electrification, whether it be ground source heat pumps like we're talking about today or air source heat pumps, we're going to see that new demand in the winter time. So these district systems, because they are so efficient, that COP value is so low, really helps to mitigate that winter peak and bring that down, so we don't have to do as much on the electric side to build out our systems to meet that demand. So that's a really good point. So this is a related question from Mindy with the city of Duluth. I think it also is germane to, again, St. Paul and Minneapolis, but what would be your guys' advice on transitioning municipally owned gas and thermal district utilities sort of onto systems like we're discussing today?
Yeah, I can take that one.
Sure.
I think that's a super interesting question, and it's quickly evolving. I mentioned this earlier, that there is a growing interest from third parties in the ownership of these district systems, and it's kind of grassroots evolution, where the installers of these systems are starting to say, you know what, we can hang on to this, and we'll just charge a fee to everybody who's connected to it and sell them a monthly amount of BTUs to heat or tonnage for cooling. And who then will be those third-party owners is really the question. Will it be private parties? Will it be those parties that used to develop and are developing solar gardens? Will it be new parties that emerge? Will it be existing utilities who step in? And whether those are municipal-owned utilities or IOUs, investor-owned utilities, I think that's a very interesting question, because those utilities can bring a lot of synergy to operating an infrastructure like a district system, whether that's billing, whether that might be some maintenance, whether it might be thinking about metering, whether it might be thinking about customers. I mean, there's a lot of capabilities that those utilities already have that could be extended to a model where they have the ownership, the third-party ownership of these district systems. So I'm very curious to see how that develops. And I think those utilities could play a very active role in that development. And then through that, using their rate base to facilitate that investment to help accelerate the rollout of these types of systems.
I also think that if there's a city like Duluth or Minneapolis, St. Paul that has a current district energy based heating and cooling system, that the Darcy system could be used right now to supplement. You could install wells to supplement where you're only using your chiller for peak times of the year.
It's a great point, Tony. Awesome. Thank you. So we've talked a lot about the project at Local 455. I know there are quite a few other projects that are ongoing across the metro area as well. I wonder if you guys could both speak to a question that Jean has here. So in an ideal world, in what types of buildings would a community start using this technology? So would that be multifamily residential units? Would that be office buildings, warehouses, retail space? Do you guys have a sense?
Well, I think if you look at a hospital, a school, most high rises and commercial buildings outside of like apartment complexes or multi-unit family homes, those buildings are already using a 4-pipe heating and cooling system. So you could implement the Darcy system in those buildings right now and have the same product, and our members would be doing the same thing that they do every day. I think, like I talked about just a few minutes ago, about the buildings that are currently all using the magic packs right now in the buildings, those I think are going to have the biggest impact if we start implementing systems like this in those buildings, because those buildings have gone away from any heating and cooling for their water hydronic type heating and cooling for their buildings. So I think implementing them into those type of building projects would probably have the biggest impact right away. And we could do it in all the other buildings right now.
Yeah. Yep. And I think it's one of those things that there's not a lack of which one to put it in. There are a number of good targets, even multi-unit multifamily, multi-unit, especially, the opportunity to bring lower cost energy to communities that didn't have air conditioning, didn't have comfort, didn't have the same level of health and physical safety, physical well-being. There's opportunities there as well. And there's this opportunity, especially from a diversity of demand standpoint, that if you look at these mixed use buildings where there's first layer of commercial and 4 layers or levels of residential on top of it, the diversity of the load profiles in those buildings too just creates natural efficiencies. So again, I think the good news is there are a lot of different target rich areas that we can go after.
Yeah, I thank you both. And I think, Brian, to pick up on your point with different energy use profiles and interconnection of those types of buildings, the example I always like is, if you have a hospital, for example, a hospital has a very different energy use profile. Instead of requiring a lot of heat, they're actually dumping a lot of heat. So they do a lot of cooling in the building. So they would be dumping heat into an interconnected district system. If you can imagine then interconnecting residential buildings to that system, those residential buildings can then just use that waste heat from the hospital. They don't have to use the extra electricity to pump it up from the aquifer. So you then take that COP value, that efficiency, and you increase it exponentially. So it's a great way to make sure that your district systems are operating at absolutely maximum efficiency. So I'm going to combine a couple questions here that I think are related from Lisa and from Ray. And this is sort of more about the Darcy equipment and the potential here. So Ray wants to know if instead of using the aquifer, you could use a body of water. So imagine, the Great Lakes in the Midwest, et cetera. And then I think Lisa is also wondering, sort of a related question, how deep are you going with those boreholes for the Darcy system? And would you have to change that application if you used an aquifer for the heat exchange or a body of water?
Yeah, really good questions. So for example, the city of Toronto takes advantage of one of the Great Lakes for pre-cooling or preheating because...
I so sorry to interrupt, Brian. I should just note we are at time, but if folks are able to stay on for a couple more minutes, I think we'd be able to answer a few more questions, and since this is such a rich conversation.
Yeah. So there are specific situations where it's being done, and it's a very natural thing to take advantage of. One of the challenges are regulations. And so you think of the Mississippi River and implications for navigation and the navigability of the river. And so those types of opportunities are limited basically to the Army Corps of Engineers. So yes, the premise of the question is a really good and valid one. Let's take advantage of that same thermodynamic benefit that bodies of water could provide, especially one that's moving like a river or a stream. So I think that could make a lot of sense. In terms of the depth, our goal is to go to keep wells as shallow as we can, where we can still get the amount of energy exchange that a building requires. There are effectively two types of aquifers that we're thinking about: superficial aquifers, which are in that, call it 50 to 150 foot depth, and then what are typically referred to as hard rock or limestone, sandstone type of aquifers, which may be 150 to 300 feet. The benefit of being in the Twin Cities, we've got 5 or 6 different aquifers at depths ranging from 50 to 900 feet. Our water supplies are typically taken out of the deepest of those. Those are the cleanest water and the most productive zones. And so that's where the drinking water is typically taken from. The Darcy system isn't relying on the potability or the quality of that water. It's really the physical aspect of it and its energy exchange potential. And that's why we aren't limited. We can go shallower if it's feasible, and then also it helps save from a cost perspective.
Like Brian said, the Twin Cities is a very unique area with the aquifers that we have. And I think that we have the potential to lead the country with some technology like this, requirements maybe for all of the buildings, so if there was a timeline, a goal set. But we've got, kind of corny, but I always say we use sun, for solar, we use wind. With the wind turbines, and the future of heating and cooling is right below our feet, and we just need to utilize it. So
that's great. Thanks, Tony. So I see some folks are dropping off. Thanks so much. I just want to say thanks so much for folks who have been able to join us today. This has been a really great discussion. We'll take a couple more questions here, and then we'll go ahead and wrap up. And if we didn't get to your question today, there are so many great questions in the Q&A box. I do apologize, but we would love to have you follow up with anyone here on the webinar today to ask your questions after the fact as well. So let's see, a question from Terry here. So how can an existing building with end-of-life steam boilers change to a geothermal system? What is the lowest temperature that can be used without a backup heat source?
That's a really good question. I know that I've talked to Todd over at Horowitz, and he has explained to me exactly how to convert a building that has a current boiler in it using the Darcy systems. I could try to chop through it, but I'd rather just provide my email address and Todd's, and he's more than willing to go into the real details about how to do it. But it is 100% possible to convert a current building and then have it use a Darcy system in place of your chiller, your cooling towers, and your boilers.
Great. Anything to add, Brian?
Tony said it well.
Awesome. Okay. All right. Let's take one more question here. This is another question from Lisa. So have you explored options to create a district heating system connecting the training center building heating grid to other buildings?
Well, we haven't explored that yet, but I've talked to some folks about it. I've talked to some friends over like the Port Authority that are working with some people that own some property around ours, and explain to them what we're doing here, and explain to them that, hey, there's a big potential that we could take what we've already started and just continue to grow on it. I mean, realistically, the 4 wells that we currently have would probably work with the abandoned Kmart that's right next door to us as well, if somebody were to redevelop that piece of property. So we're sitting on a perfect spot. We have perfect aquifers underneath our building. So I think there's a ton of potential if there was any development that was going to be done around our area. And I hear talks that, they're looking at developing around this entire area, that I think it would be foolish not to utilize what the Darcy system can provide.
Great. Okay, well, with that, I think we're going to go ahead and wrap up. Thank you so much for everyone who's stuck with us for a couple extra minutes here and for all of the great questions. So on behalf of everyone here at Fresh Energy, thank you for attending. Oh, Tony.
I just want to leave my email address, and
yes,
it's Tony P at local455.com.
Thank you so much.
I'm Brian at darcysolutions.com.
Okay. You guys are brave. There are lots of good questions, so I imagine you're going to get some good follow-up. So thank you so much for being willing to take that follow-up from all our attendees today.
Yeah.
And again, especially thank you, Brian and Tony, for sharing your time and your expertise with us today. This has been a really great conversation. And just for folks to know, a recording of this webinar is going to be posted on our website, so freshenergy.org/publications, and on our podcast, which is called Decarbonize, the Clean Energy Podcast, which is available on all podcasting apps. You can learn more about Fresh Energy's work at our website, www.fresh-energy.org. Here you can subscribe to our newsletter, check out the latest on our blog, and make a donation today. Again, thank you so much to everyone who joined us and whoever was going to listen subsequently on our podcast. Thanks so much, and see you next Thursday.
Thank you so much, Margaret. Really enjoyed the opportunity.
Yeah, that was fun. That was good. I think it was a really great way to get what we're trying to do out there to a lot of people. So
thanks for lending your voices, guys.